Okay, here's a quick video on lesson 2.1. Um, so the first thing is the explanatory and response variables, okay? So if we're looking at quantitative data in a couple of days, we're going to think about our x variable is going to be our explanatory variable, and our y variable is going to be the response, okay? Now, just in general terms, an explanatory variable is kind of like our variable that we're kind of putting in. For example, we want to know the response of this drug. Okay, so how much drug is given is sort of the explanatory. Our response would be, the results. All of our response is the result sort of idea. So here's some examples. We want the opinion about tax reform and political party membership. Okay, so we want to know the explanatory would be the political party that people are in. So does knowing that somebody's a Democrat or Republican, okay, so that's our beginning thing. And then does that tell us about something? The measurement that we're having would be their opinion about tax reform, okay? The anger level, low, medium, or high, and whether or not a person has heart disease, okay? So our explanatory would be, are they low, moderate, or high, okay? And then the second part, what we're measuring from that is whether they or not they have heart disease would be the response to it, okay? Some relationships, there isn't a clear explanatory response. For example, eye color and hair color. It doesn't really tell us which one we're doing first and which one we're measuring as a result of that first one, okay? But most of the time we're going to talk about it again, okay? Okay, the next topic is a segmented bar chart. Okay, they're segmenting bar chart. So here's an example in the book. We had talked about one study where they took 200 kids and they surveyed what kind of power they wanted, superpower, so invisibility, and then they separated by males and females. So the females and males were exactly the same here for invisibility. Super strength, the males wanted to be super strong, the females didn't necessarily. Telepathy, females definitely wanted that, males not as much, etc. Okay, so what we would do with a segmented bar graph is we make something like this. Okay, so we take just the females and we start putting them up. Okay, so invisibility was 15%, so females goes up to 15%. Okay, next we had super strength for females was only like 2%. So we're only going to add in like 2% more right there. Okay, and we keep building. Okay, telepathy was 35%, so we add another 35% into that. And then we add the 30% in, and then we add in the last 15%. So by the end, we have 100% of our female data there. Okay, and then you do the same thing for the males. Males, 15% there, and then we add in another 20% there. Okay, so that's up to 35 then, right? So 15 plus 20 more. Okay, so you get that idea. That's the idea of a segmented bar chart. To be honest with you, it doesn't matter what order these are in, but it should be consistent from this side to this side so you can kind of compare them. So by looking at this, we have 100% and 100%. We can say that the female is a lot less here than it is over here. Okay, we could see that here too. But okay, so that's how you make your segmented bar graph. Identify the variables. Draw your axes, scale the axes, make sure you go up to 100% because we are going to have 100% of our data here by the end. And then we're just going to put everything in. Okay? Make sure you do include which one is which, though. Either write it in or use color or different kinds of shadings or dots or whatever. Okay? The next idea we're going to talk about is there an association between two variables? Okay? So if we know something about one variable, if we know, for example, the political party, if we know that somebody's a Democrat, does that help us predict or tell us about the other variables? Okay. So if it does, if I know that somebody's a Democrat, it probably is going to tell me who they're going to vote for, right? So that would have an association, okay? So voting preference and party preference would have an association because knowing one thing tells me something about the other thing, okay? So here's an example of that, Okay, so the Titanic in 1912, yeah, you guys all know the Titanic, a big boat sunk, right? So who survived? Okay, so here's some information that we have here. Survived, there were 197 first class people who survived, 94 second class, and 151 third class. Okay, first class would be the rich, middle, and lower income people in the ship. And these are the amount of people that died. Okay, so total there were 319 first class people, second class, and third class. Okay, so if we're going to make a segmented bar graph of this, okay, so first class, okay, we got to find a percentage first. Okay, so grab my calculator here. So we're going to make your axes here. Here's our first class. I'm going to go by 20s, 20, 40, 60, 80, and then I get up to my 100%, right? Okay, here's my percentage. So of those that survived, okay, we have 197 divided by the 319 people total, and that gave us about 62%. Okay, that's survived. Okay, and then we had 122 divided by the 319, okay, which is about 38%, which takes that up to 100%, right? Okay, so 38% died. Okay, that's your first class. Now, you want to do the same with a second class, and you want to do the same for the third class. Okay, so that's how you build it here. So the second class, I'll do that one. 94 out of the 261 people was about 36%. Okay, so that comes up to about here. 36% survived. That means the rest of them, up to 100%, died. So 100 minus 36 would be 64% died. Okay, third class, we had 151 out of the 476. Okay, so we had 32%, so even a little bit less of the third class. 32% survived. That means 68% of the people died. Okay, so that's how you build your segmented bar graph. Okay, so let's talk about the association. Do we know that if somebody was in first, second, or third class, was there a different percentage of people that survived? Okay, so if I know that somebody was first class, did they have a different outcome, probable outcome, versus if somebody was second or third class? Okay, the answer is yes. If somebody was in a first class cabin, they were much more likely to survive than if they were in the other classes. Okay, so we would say there is an association between the two variables of class and survival. Okay, yes, there is an association between class and survival. Okay, and you can see that there. Okay, so what would it look like if there was not an association? Okay, well, if we go back to that invisibility and superpowers, if there was, we know that if you were female, you preferred one thing over another thing, right? And if you were male, you preferred one thing over another thing. So gender does have an association with the type of superpower they would want. Okay, now if there was no association, it would look like this. Males and females would have the exact same proportions, okay, exactly the same. And then we would say there's no association between gender and the type of superpower they would want. Okay. Okay, so let's look at this example here. Actually, we've already talked about that. So we know that the class does have an impact and an association with whether they survived or not. Okay. Now, this is kind of an interesting thing here too. It may be true that having higher class when they travel in the Titanic increased their chance of survival. However, there isn't always a cause and effect relationship between the two variables. Just because you were in first class didn't cause you to survive. Okay, so here's an example of that. A recent study proclaimed that people who are overweight are less likely to die within a few years than people that have normal weight. Okay, does this mean that gaining weight will cause you to live longer? No. Okay, there's another variable in there too. So the study included smokers as well. And smokers tend to be a little thinner and also are more likely to die in a given short period of time. So smokers increase the death rate for the normal weight people, making it look like being overweight was better. Okay, so and we'll look at some examples in class where cause and effect isn't necessarily true. So just because there's an association doesn't mean that there's causation. You might have heard that in some other classes as well. We can have an association, right? First class and survival, has an association, but it doesn't mean that one causes the other. Okay. So here's an example. I'll do one more example with you guys here. Is there a relationship between gender and relative finger length? Okay, so they took 452 people, high school students, and they made this table of how long their index, ring finger, and in the same length, which one was longer, or if they were the same length. Okay, so let's make a segmented bar chart here. Okay, so we have our females and we have our males. I'm going to go by 20s again. Okay, so our females for the index finger were 78 out of the 212, which gives us about 37%. Okay, and I'm going to say that, here's my key over here. I'm going to say the ones that are striped this way is going to be my index finger. Okay, now we'll go with the ring finger. We're 82 out of the 212. Gives us 39% almost. Okay, so if you take 37 plus the 39, okay, it takes you up to about 76. Okay, and I'm going to make these stripes going across like this. Okay, so if I have stripes going across, that's going to be my ring fingers bigger. And then I know that the rest is going to be the people that are same length. So I can either figure out that percentage, or I can, subtract it from 100% here. And that comes up to be just about 25%. Now, they might not always add up to be exactly 100% because I rounded these and so forth, but you get the idea, okay? And you can get some, in this one I'm going to make these this way. Okay, so there's my females. Okay, now I can do the males. So the index finger for the males would be 45 out of 240, which would be about 18, almost 19%. Okay, so that's about 19% for my index finger. Okay, my ring finger, 152 divided by 240 gives you about 63. Okay, 63 in addition to that 19% would take you up to 82. So look, what does it look like for males? Looks like males have their ring finger a little bit longer than their index finger. So it's kind of interesting here. Look at mine. I don't even know. Yep, my ring finger is a little bit longer than my index finger there. Okay. Anyway, and then we would have the rest of them there. Okay, 82, that would be about 18% there, would be the same for males. Okay, so there's our segmented bar chart. Number 2, is there an association between gender and finger length? Okay, does knowing that somebody's a male or a female, does that give us have an impact on the results of which one's bigger? So yes, there is an association. Okay, knowing that somebody's a male, they have a higher probability of having their ring finger longer than their index finger. Okay, so they're not the same percentages. Okay, so that is what we did here in section 2.1.